So our next speaker reminded me that we need to keep on time. Thank you, George. I'm turning it over to a new moderator, Bruce Rittman. He's with Arizona State University, and he was our very first Clarke Prize recipient. Bruce?
Thank you. Thank you, Jeff. Okay, so we have a wonderful session here on the challenges of urban water sustainability. It's wonderful because it's a great topic, and we have great speakers, but I wanted to say I'm really thrilled to have George and Dick on the program in this session, because not only are they great, eminent engineers, they're also really great guys, and I really enjoy sharing the time with them. So, okay, our first speaker is someone who really needs no introduction. Actually, he often doesn't get an introduction because people can't pronounce his name. But if you're really an environmental engineer, you can do it. So our first speaker is George Tchobanoglous, who's at the University of California, Davis. He's been there since 1970. Whoa, yeah. He's now a emeritus professor of civil and environmental engineering. Now, George is really famous for his work on reuse and for UV disinfection, and because of all that, the great contributions he's done in those areas as well as in environmental education. He was awarded the Clarke Prize in 2003, and then he was elected to the National Academy of Engineering in 2004. So with that, George, please.
In sympathy to our moderator, I took off my tie. But in point of fact, I cannot tell a lie. I just plain forgot it. So, anyway, what I'd like to do today is talk a little about the future of direct potable reuse. And what I'd like to do is talk about it in 4 sections. I'd like to mention the framework document that we've been working on that has been produced, and to give you some perspective, and then to really go through what is potable reuse, to give you a brief historical perspective, some issues, and future challenges. The framework document was prepared by an NWRI independent advisory panel. I served on the chair, and I had wonderful panel members. But when you serve on a panel like this, there are some consequences. When I first started this, I had dark hair. But what do we want to do with this framework document? We really wanted to provide and to identify the key elements that make up a DPR program, and to establish a framework for evaluating the issues that have to be developed. And we need to develop guidelines, and what kinds of things do you need to think about? So with that, let's talk a little about what is potable reuse. And right now, there are really 3 different types of potable reuse: de facto indirect potable reuse, indirect potable reuse, direct. And then we'll talk a little about the technologies, some energy and cost implications, and some driving forces. Now, indirect potable reuse really is this diagram, and Jeff put it up earlier. And I must say that whenever I go down to San Diego, I always feel good, but I feel especially good because I always bond with myself. And, also skated, if you go skiing in Utah and come to San Diego, same thing. And it works out that all of us have bonded with ourselves in a number of different locations. Now, how did we get this way? How did we decide to put all this waste into rivers and so forth? And now what I'd like to have you do is I'd like to have you read this quote, and it's from Alan Hazen. And Alan Hazen was famous for the Hazen-Williams pressure computing formula and for a book called The Filtration of Public Water Supplies. But please take a read. Just read this. And when you think about it, he set the tone for the next 100 years. He absolutely set the tone for the next 100 years. And as you think about drought and reduced flows in rivers, the wastewater is going to become a much larger fraction. And the point is that when the Clean Water Act was passed, it was not passed for this problem, it was to make streams swimmable and fishable. And so we are still suffering from this kind of an approach from 100 years ago. Now, if we talk about indirect potable reuse, the key features of an indirect potable reuse system are the presence of an environmental buffer. And in the upper diagram, we go to groundwater, and the bottom, surface water. That's a picture of San Vicente, and that's typical injection wells at Orange County Water District. So when we talk about direct potable reuse, what are we talking about? We're talking about two types of direct potable reuse. In the first one, advanced treated water is introduced either into a small reservoir or mixing chamber or at the front end of a water treatment plant. And so the concept there is that we're going to introduce it at the front end. The second type, which people often mistake and want to call tap to tap or pipe to pipe, is one in which the advanced treatment facility is permitted as a drinking water plant. And you see, at this point, no one knows how to do that. In other words, if you have a facility that's producing advanced water and it's also going to produce drinking water, do you separate it by distance? Do you separate it by process? What is it you do? And we really don't know this. And so really the focus of our efforts in the panel were on the upper part. That is where we take advanced treated water and we introduce it at the front end of a water treatment facility. Examples of DPR, Big Spring was mentioned, and Windhoek, Namibia is an example of direct pipe to pipe. Now, the question that Karen brought up, and it really is a very important one, when you put water into a surface water reservoir, at what volume of surface water reservoir does it become direct potable reuse? In other words, how do you compute that? What do you do? In a proposal that the city of San Diego is submitting, they're talking about additional treatment, both with ozone BAC and disinfection with free chlorine. But again, these are issues that all of you are going to have to deal with. If we look at technologies, probably the gold standard for advanced treated water is the Orange County Water District system. And it was put in based on a lot of experimentation over a number of years. And we have submerged microfiltration, reverse osmosis, advanced oxidation, water conditioning. And so there's a lot of concern about how can we do away with reverse osmosis, especially for inland locations. And a lot of work is going on there, and in the next 10 years, you will see a variety of new processes come online, which are really rather dramatic. If we just look at the facilities themselves, we have in the upper left the microfiltration. We have the cartridge filters on the upper right. Now that's an interesting story. Why do you need cartridge filters if you have microfiltration? Well, the reason is that the chemicals that you buy, the purity is not high enough, and if you don't filter out contaminants, you will damage your membranes. So it's an interesting conundrum, because if you buy pure lab-grade chemicals, the costs are really rather prohibitive. Obviously, we have reverse osmosis and advanced oxidation. So now what I'd like to do is look a bit at what does DPR cost. Well, the number circled in red there, $685 per acre foot, is the unsubsidized actual cost of the water at the Orange County Water District, unsubsidized. Now, when that first went in, everyone laughed because you could buy water at $100 an acre foot. It's now moving up to $1,200, and by my own reckoning, I feel that water is underpriced by a factor of 3. And so what's going to happen is imported water is going to run around $2,500. And the production of this water at Orange County is a bargain by comparison. Let's take a look at energy. And we can compare advanced water treatment with, let's say, the energy required to transport water from Northern California. And the amount required to transport the water is larger by a factor of 3, roughly. So all of a sudden, from being a kind of stepchild, this system has become front and center, and it has become cost effective and will become more cost effective in the future. What are some of the driving forces? Well, from my perspective, the most important one is that water is significantly undervalued now and is going to increase by at least a factor of 3 in the next 5 years. And I see this trend across the country. There are obviously other forces, and we don't need to go into those, but I just wanted to highlight. The next question we want to ask is, where does deep potable reuse fit in the water portfolio? And from my standpoint, from water sources, I think we're talking about local surface water, local groundwater, imported water, potable reuse, desalination, and stormwater. These are all sources. But very often people confuse measures with sources. And when you talk about conservation, it is not a water source. It's a reduced usage. And this reduced usage is going to have some severe implications. So now what I'd like to do is just give you a little historical perspective. This was from a talk given in 1930 in Southern California. Reclamation of sewage in Southern California is coming, whether we like it or not. It is not a question of sewage disposal, but one directly related to a legitimate increase in water supply. Where have we been for the last 80 years? This was 1930. Now, I would like you to read this one because this is a little California angst, but take a read. You can see that he was concerned. But here's the more interesting thing. Look at the original treatment process he proposed in 1930. It looks very similar to the ones we're now doing. Very similar to the ones that we've now implemented. And so the whole idea is that it was sitting, this technology was sitting out there. It was understood, but never implemented. And that really, the politicians at that time did it in because they wanted to bring Colorado River water in. And that was what happened to Gaudi. Now, some issues that are going to impact both IPR and DPR. And one of them, first one is, these are all secondary treatment processes that I've put up. And the important thing is they all meet secondary treatment requirements. But they all produce a different quality of effluent. And this chart is not to be read, but we've summarized all these different qualities. And the idea here is that what's going to happen is we have to think differently. And here's what I mean by that. If I asked you, what's the purpose of wastewater treatment? Most of you might say, well, it's to produce an effluent that's suitable for discharge to the environment, whatever that might be. On the other hand, what if I asked the question differently? What if I told you the end point was to produce a water that we could process further with membrane technology? How would you design your treatment process? It would look different. It would be different. And you're going to hear about a couple of different options in the following session. But the point that I'm making is that we need to rethink this. We need to rethink wastewater treatment. I'll give you another example. Here is a cloth filter that we're now using as a replacement for primary sedimentation. Now, here's what's really interesting. People talk about filtration and they'll say, well, you know, your L over D is not very good. L over D being the depth over the diameter of the particle. But if you look at the cloth filter and the depth when it's folded over, the L over D is exactly the same. Now, what's important about this? What's important about this is that you produce 5-micron particles. you change the treatment kinetics dramatically. And so there are these many opportunities like this that are coming down the pike. It's just that we've been slow to implement them. Jerry talked about climate change, and I talk about it the same way. Areas that are wet are getting wetter, areas that are dry are getting drier, but the more important thing is the intensity of the rainfall events. Because look what happens. For a lot of our systems, wastewater treatment systems are designed like bathtubs. Water in, water out. And the number of systems that are being washed out annually across the country is staggering. All that good work that we've done for 360 days of the year disappears. And so we're going to have to think far more creatively about how we design treatment plants. Now, the next thing is impact of conservation. And here, if we start at the upper left, up until about 1992, the per capita usage was relatively constant in any municipality. Obviously, it went up and down depending on where you were in the country. But in 1992, conservation started to kick in. Now, what's happened is that there's another dashed line there. We don't know when we're going to reach that. The reason is, how many washing machines are out there with 30-gallon tubs? In 10 years, there won't be any. The water use is going to drop. Now, this is going to have dramatic implications on a variety of things. Across the country, this is what the picture looks like. And you see we have indoor use right now across the country is about 60, and by 2030, I estimate it'll drop to 45. But in California, it's very likely that we're now at about 45, and that the number in 2030 is going to drop down to about 30. Now, the interesting thing is, when that number drops down to 30, gray water systems don't begin to make sense. It's a kind of unintended consequence. Everyone wants gray water systems to work. But when you drop the water level that low, given what you use and so forth, they don't begin to make sense. And that's a problem. Another problem is that when we drop the water use that low, we get deposition of solids. And what we're finding is that we're getting hydrogen sulfide produced. And the hydrogen sulfide is transported by the skin friction of the water that moves around the solids. It's going down, and the rates of corrosion in many parts of the country have increased by a factor of 8. Now, the amount of money we will have to spend to retrofit or correct our wastewater systems will dwarf everything else that we've done. Will absolutely dwarf. And so what we have here are a series of unintended consequences. We always thought we were doing the right thing. Carlsbad was mentioned, and they're going to have a pipeline from the desal plant to find enough dilution water. Well, what's wrong with our water systems? They were screwed up because steam pumping was not reliable. Of course, I was around in those days, but steam pumping was not reliable, and we put both our treatment plants and storage reservoirs up high in the mountains. So if you're up high in the mountains, the pipes are about this big around, and when you're on the coast, they're this big around. There's no dilution water. So you have to now put in a pipeline to go find dilution water. Also, another interesting phenomenon is that there is about 30% excess tankage capacity available across the United States. Now, it's not uniformly distributed, but because of these reduced flows, we have all this available tankage. And so the opportunity for rethinking the way we do wastewater treatment and the way we manage storm events is rather remarkable. As an example, I showed you that cloth filter. It takes about 1/5 the space of conventional primary clarifiers. So if we replace that, we could now use the clarifier capacity for flow equalization, return flow equalization, a variety of different concepts. And so you have to be bold in your thinking in terms of what can we do? Can we apply some new technology? And if we apply it, what are the possibilities? All right, just a few words about the future. And from my perspective, I think it's important that we move ahead with DPR now. We really do have I feel the safe public health concerns under control. We have the treatment technology under control. But in the framework document, a number of needs were identified that would enhance what we do. Because we need to improve what we do. It would enhance it. And they were regulatory, technology, and public outreach. And I'd like to say that as we move ahead, we should move ahead with where we take advanced treated water and we introduce it at the front end of a water treatment plant. Here in California, if we were to take the lower case, the finished water, here's the problem that most people don't think about. Water comes in at about 40, and it goes out at about 68. So after treatment, if you were pipe to pipe, you'd tell all the residents you have to change your plumbing. The taps will now read hot and tepid. So when you open your water, how are you going to feel about this water that's sort of lukewarm? Well, so what does this mean? Well, this means we're going to have cooling towers. We're going to have a lot of different technologies. This is not the same old picture that we've always been looking at. If we look at regulatory needs, we're going to need national guidelines and regulations. But more importantly, we need to start thinking about whether advanced treated water should be considered as a third water source. We have groundwater, surface water, advanced treated water. And down the road, stormwater. But the problem with stormwater is we don't know quite how to capture it. And so these are really important issues that all of you are going to have to wrestle with, because it is a water source. And as we get more restricted, clearly it will not solve the water problems, but it'll be a component of a portfolio. It'll be a piece of the portfolio. We need new training programs. Should these systems be operated by wastewater treatment plant operators, water treatment plant operators, or a whole new category called equipment operators or advanced equipment operators? And this is an issue that we're going to face across the country. Why is it important? Because the current crop of operators is going to retire within 20 years. And we have not developed the follow-on operators that are going to be needed for these systems. And their level of sophistication is going to have to be much greater than it is now. On future technology needs, really what's important here is we need to understand more clearly the interrelationship between multiple barriers. How are they connected? You know, we have always used the series model, but we need to use a neural network model as we start to think about these things, especially as you want to think about resiliency and robustness and all of these other issues. Also, we're going to have someone step up, or maybe a governmental agency step up and demonstrate the effectiveness of a facility without reverse osmosis. Now, Orange County spent 20 years studying this process, starting with Factory 21. Everyone now wants to come in under their wing. No one wants to do the work. And we have to think clearly about how we're going to do this. Now, the other thing that's truly exciting is, just at this conference, I ran into two people that are developing new membranes. The change you will see in membranes will be astonishing. And in fact, this is heresy, but I'll say it anyway, you could imagine the day where we don't use biological treatment. You don't seem convinced, but from a public outreach standpoint, what do we need to do? We need to develop appropriate and consistent terminology so that when we talk to each other, I understand what you're saying and you understand what I'm saying. Now, finally, and I'm going to ask a favor. All of us are going to read the first one together, if you wouldn't mind. Come on. Wastewater is a renewable, recoverable source of potable water, resources, and energy. And that's the paradigm shift for the 21st century. Along with that then comes another question, and especially for the young people in the audience that are going to design these systems, and that is, what is the optimal use of the carbon in wastewater? What is the optimal use of the carbon in wastewater? Is it nutrient recovery? Is it product recovery? Is it energy recovery? We're going to have to rethink all these things. And it's not going to be one model fits all. We're going to have a variety of different technologies. But these two things are really going to change the 21st century. And with that, I'd like to thank you for listening.
All right, George has allowed some time here for a few questions, so please identify yourself.
I'm just curious. You mentioned that water is underpriced by a factor of 3 by your calculations. Could you elaborate a little bit more on how you got to that figure?
Well, I've taken a look at some of the subsidies across the country and how they've changed with time, and working with those numbers, and also a friend, Bob Rauscher in Colorado, looking at it, and then also just simply plotting up what's happened in California. If you just plot up the data for, let's say, imported water and or ag water, you know, it wasn't so long ago, ag water was less than $100 an acre foot. So it's a combination of all those things.
Thank you.
For here, Joan Rose has one.
So I have a question that sort of goes to the first speaker, what Karen was saying, and I think she did a great job of talking about, you know, these issues. And I'm kind of wondering, like, do people really get we're in a new normal? Is there an understanding of that? And where does this paradigm shift have to happen? And where does it have to happen first? Does it happen, is it within the profession? Those of us that work in the water, do we have to embrace this? And I think we already are to a certain extent. But then it has to go to the next level. It has to go to the new normal. And I think that the governor being interested, I think we have to have our politicians interested at these high levels as well, or we're not going to get this paradigm shift. So, I don't know, could you comment on that?
Well, certainly, being in education for a number of years, we're not doing a good job keeping up students with new thinking, basically. You know, if you think about civil engineering education, it hasn't changed in 100 years, although we did drop railroad engineering as a concession. You know, we said, well, you know, we don't need railroad. You know. But basically, it hasn't changed. And look, today's student, I've been serving on a committee, and it's really interesting. Today's student that comes in is a problem solver. Why? Because they've all played games on iPads or whatever. And the game you play is you don't want to be destroyed, so you have to figure out what to do. And that's, in many ways, the way we should be doing our education. But it just requires a lot of commitment, a lot of time. And, you know, on the technologies, I ran into students that just finished, and I said, well, you know, what about replacing primary sedimentation? And they said, what? You can't do that. Wait a minute, why can't I do that? And the whole point is that we need to bring in some of this different thinking. And you don't have to change anything that you're doing, but you have to put it in the context of, we ought to think, for example, on wastewater treatment. We've done it just this way for, again, 130 years. But what should the optimal use of carbon be? You know, and you can get a spectrum of answers depending on where you are. If you have to remove nutrients, I would certainly say nutrient removal is a prime area. So again, I think that the education, I think also the initiatives in the state, Joan, are starting to help. I think there is really a recognition, and I'm encouraged by San Diego. For example, 1972 or 73, about 23% said drinking recycled water was okay. The most recent poll, 75+%. And so what does it take? It takes education. It takes commitment. It takes a uniform vocabulary. It takes a willingness to work with the public. We've all got to spread the message. But if I asked us collectively to define, before having seen any of these slides, if I asked you collectively to define direct potable reuse, I would get any number of different definitions. And so our terminology is really a limitation. And I think that it's one of the areas that we all need to think about, you know, and especially as we move forward.
All right, we have time for one more question, and it's in the back here. So there's a microphone somewhere.
So the question I had was related to micro-constituents. We've been hearing all about those, studying those from a treatment and toxicity standpoint for a while now, and it seems like we've proven that maybe the relative risk is not there. Is that whole part of reuse going away and wastewater treatment in general? Is that a thing of the past now, worrying about EDCs and pharmaceuticals?
I think that worrying about some of them is in the past, but there will always be new compounds that are coming down. And my own vision of direct potable reuse, the agencies, first of all, the agencies that undertake it should be willing to provide 24/7 operation of the facility. So I don't see it physically for very small systems. And in the same way that I don't see gray water systems when water usage is so reduced that the value of the system will far exceed the value of the water. So I think that, you know, all of these issues, I think, are being resolved as we move forward. But I think it's an exciting time, and the fact that you're here, and I got at least to give you potable water, resources, and energy, I've achieved my goal.
All right, with the goal achieved, let's thank George again.